All right, in the last little section here, we're going to go over the concept of solubility, which is just basically the rate in which things dissolve in substances, is essentially what it means. So solubility, technically, is the maximum amount of solute that dissolves in a given amount of solvent at a constant temperature. We usually measure this in grams of solute per 100 grams of solution, solvent, all right? So there we go. Couldn't get my pen to work. There we go. So solubility is a very important characteristic that's an identifying characteristic for all substances. Every substance has its own amount of solubility. It's like a fingerprint, or its density, or its boiling point. It's one of those defining characteristics. So take a look at over here at the chart. You have basically all white powdery substances here: table salt, baking soda, and table sugar. If you have solubility, let's say at 100 grams of whatever substance at 20 degrees temperature of water, then basically what that means is you can get 36 grams of table salt to dissolve in 100 grams of water at 20 degrees. Contrast that with baking soda. So baking soda is only 9.6 grams. And take a look at table sugar. Man, that is a lot of sugar that you can dissolve in water. Now, all three substances are white powdery substances, but look, you might notice that what kind of substances they are. So NaCl, that's an ionic compound, right? Baking soda, that's another ionic compound. And sugar is molecular compound. So that has something to do with it too, the type of compound that it is. So in terms of solubility, there's three types of solutions that you can have. The first one is called saturated. A saturated solution is the amount of solute that is dissolved in a solution at a given temperature. In other words, it is full and cannot dissolve any more solute. So take a look at our picture here. As you see, this looks like some salt water or something. You put the salt in here, and down at the bottom, it's all still in a solid form sitting at the bottom. We would say that this solution is saturated. In other words, it's full. It can no longer dissolve any more of the solute. And so anything else that you put in is just going to fall down to the bottom. All right, so the opposite of saturated is unsaturated. That means the solvent can hold more solute at that given temperature. So if you're making tea, you put some sugar in the water, it all dissolves and you can't see any at the bottom. That means you can add more to it because the solution is unsaturated. Supersaturated is the third type of description here. It contains more solute than it can normally hold at a given temperature. So this is a special circumstance that happens under very specific conditions. So usually what happens is if a saturated solution is cooled very slowly, sometimes the extra solute will remain dissolved, but it's very unstable. In other words, if you add just a little bit more, it's going to cause it to change. So a great example of this is rock candy. This rock candy is, you all know how to do that. So how do you make rock candy? So you take syrup, which is basically sugar water, and you heat it up to a very high temperature. The higher the temperature, the more it can hold, more sugar it can hold. And then you gradually cool it off over time, very, very, very slowly, and cause it to crystallize. So this is a rock candy is an example of a supersaturated. Sodium acetate, I have a video that I'm going to try to find and post on here too. It shows you how that works too with its supersaturated form. All right, the last little part here is about the three factors that affect solubility. The three factors that affect solubility, which we've already discussed to some degree or another, is polarity. We follow the description here: likes dissolve likes. In other words, polar dissolves nonpolar, nonpolar dissolves nonpolar. They don't dissolve each other. So polar and nonpolar substances, as we've already learned, do not mix, and so therefore they will not dissolve. So which one does the dissolving? This is the next part we need to discuss. So the less dense always dissolves the more dense, right? So take your fingernail polish example that we used in class the other day. Fingernail polish remover is called acetone, and it's very, very, very not so dense. And it is less dense, so therefore it will dissolve the fingernail polish. So water does not dissolve fingernail polish because it is not, because water is polar and fingernail polish is nonpolar. So in art class, you probably remember the difference between oil and water-based paints. Oil paints you can't wash out with water, but water-based paints you can. Another concept that applies to this, and those of you who remember from biology, there's certain vitamins that are water soluble and certain ones that are not water soluble. They're fat soluble. So a lot of vitamins like vitamin C, vitamin C, vitamin D, these are all, not D isn't, sorry. Your B vitamins and your C vitamins are water soluble, so they get dissolved in water. Soap and other detergents are what we call bipolar molecules. One side likes the water and the other side likes the dirt. So this is how they mix, basically. As you can see, one side of the solution, one side of the molecule is attracted to water, the other side is attracted to oil. So it's one of these types of molecules that bonds things together, such as oil and dirt. So these are called bipolar because one end has one polarity and the other end has a different one. So the second factor that affects solubility is temperature. Generally, solubility increases as temperature increases. You have a nice little chart here with different types of substances, different types of compounds. As you can see, most of them are ionic compounds. But if on the side here, the bottom, you have temperature, and on the other side here, you have solubility. So the trend for most things is a positive trend. So the more heat you add to the water, the easier it will dissolve the things. There's just a few substances that don't fall into that trend. Here's one down here, cesium sulfate, that actually decreases with temperature, which is kind of odd. But this table here was very useful. So you can actually use the graph here to figure out what the solubility is for certain compounds. So for instance, if you can have 40 grams of sodium chloride at 90 degrees. All right, so all you gotta do is pick out your point on the graph where the two things intersect, and that is your solubility point for that particular substance. So each substance has a specific amount it can dissolve in a solution at a given temperature. This chart will be on the A-level test actually, so take a real close look at it. So how does this work with the different types of solution. So if you, at 90 degrees, if you were to put 50 grams of solute in, what would happen? What type of solution would that be? It would obviously be what? Saturated. So you would basically have 10 grams of salt that would sink to the bottom of your solution. So 40 grams would dissolve. The 10 grams that's left over would sink to the bottom. Pressure is another thing that affects solubility. This can be easily demonstrated in scuba diving because this is the number one factor that can lead to whether or not you can scuba dive properly or you can have a scuba accident. So as pressure increases, solubility increases. In other words, over here, if you have a given amount of air particles in the air, basically, and if you change the air pressure, you make more of these air particles now be forced into the solution. So pressure can definitely affect how much a substance dissolves in another substance. So for human beings, we have gases that dissolve in our blood, which is essential for us staying alive. So a scuba diver has to have a very good understanding of this concept, otherwise they can get what's called the bends. If a scuba diver is down below the sea level for an extended period of time, their body adjusts to the different amount of pressure. And so therefore they have a certain amount of gases that are dissolved in their body. So when the scuba diver comes up, there's less pressure, so what happens is these gas particles that are in the blood, they actually now come out in the form of gas inside your body. So this is a very uncomfortable situation, which is very, very, very painful and is actually deadly and life-threatening. It's called the bends, and it gets its name because that's what it makes you do, bend over in agonizing pain. So if you ever want to go scuba diving, you have to be trained on this concept. You also see this in, like when you shake up a carbonated drink and take off the cap. It's the same process. You're changing the pressure, and when you open the cap, the pressure changes, and what happens? The gases all rush out. Next, you got the concentration. So concentration also affects solubility. So the amount of solute dissolved in a specific amount of solvent is important. So you have a dilute is a term that means when you have little solute dissolved in the solution. You have concentrate, which means you have more solute dissolved in the solution. Think about when you're making tea. The longer you leave the tea bag in the solution, the more concentrate it becomes. So there's basically three ways in which you can change concentration. You can add solute to it, you can add solvent, or you can remove the solvent. So adding solute basically means like whatever you're trying to dissolve, you just add more of that. And so that'll affect the concentration. Solvent, if you add solvent, that's going to make your concentration weaker. You add solute, it's going to make it increase. And removing the solvent's a little bit tricky. It's very difficult to remove the solvent. And one way is by distillation, when you boil the substance and remove the water. So for the last assignment that you guys have, you have one more graphic organizer that you're going to have to fill out. You can use this as a template and dwell about the solubility and the factors that affect solubility and the three types of solution and the types of concentration terms, okay? So you got to figure out what goes in this box here. All right, there's something that goes there. What do you think should be there? Okay, so you guys work on this. This will be due before next class, so go ahead and finish this up and submit that. Talk to you soon. Take care.